Hi guys, welcome to the next section, Connectors, Akka, Spark, Kafka and Cassandra. In this section, we will be analyzing the connectors, which are the software pieces that enable SmackStack technologies to communicate with each other. Here we will look at the relationship between Akka and Spark, then between Kafka and Akka. And finally, we will look into the relation between Kafka and Cassandra. Now we move on to the first video of this section, Akka, Spark, and Kafka. In this video, we will be looking at the relationship between Akka and Spark and Kafka and Akka. Let's first begin with Akka and Spark. We will be using Lightbend technology to create the project. This is the code to create the project. We named it as Akka Spark Example, and we will be using Spark Streaming Scalar Akka template of Lightbend. Come on, let's run it. As you can see, the project is being built and the templates are being fetched. Let's go to Project folder and type Activator UI to open the project in browser window. This code opens the project in the browser. As you can see here, the project is being loaded. Now we need to click on Code, select SRC, and open the folders inside it, and open the streaming app Scalar file. We have the streaming Scalar file here. We start developing the Spark streaming application by creating a Spark conf, followed by a streaming context. This is the code to do that. This part of code gives us a context to access the actor system that is of the type receiver input dstream. Now we have a dstream, let's define a high-level processing pipeline in Spark streaming. This is the code for defining high-level processing pipeline. The print method is going to print the first 10 elements of each RDD generated in this dstream. Nothing happens until start is executed. So we give the start command here, ssc.start. With the context up and running, the code connects to an Akka remote actor system in Spark streaming that hosts the helloer actor and prints the message as shown here and displays them all to a standard output. Let's run this. You can see that the streaming action is being run. We will test the result now. We get the warning messages. After this, we can see this output, hello from streaming with Scalar and Akka, as you can see in the code. This tutorial has introduced Apache Spark with the Spark streaming extension and demonstrated how it can be used for processing near real-time data streams that are handled by a single actor in an Akka actor system. We will now learn about Akka Kafka. We will be using Lightbend technology to create the project. This is the code to create the project. We name it as Akka Kafka Example. Come, let's run it. As you can see, the project is being built and the templates are being fetched. Let's go to Project folder and type Activator UI to open the project in browser window. This code opens the project in the browser. As you can see here, the project is being loaded. We will now go to browser window. Now we need to click on Code. Let us learn more about the Akka and Kafka now. This example is about two actors who are playing ping-pong with each other. Here the actors won't be sending messages to each other. Instead, they will place and read messages from Kafka's topics. Now select SRC and open the folders inside it and open the sample folder inside the Scalar folder. Here you can see our files pingactor.scalar and pongactor.scalar. Let's look at the rules now. Here we have two actors, pingactor and pongactor, who are registered to Kafka topic and respond to the message with ping-pong message, when the message will be submitted to the topic. The game will be terminated by pingactor after 3 messages by sending poison pill to self and game over message to pongactor.topic. Let us first set up the project. This is the build.sbt file. This is the code. We first need to add this dependency. Next, we need to configure the Kafka settings. For that, we will go to Application, main.scalar file, and here we need to add this code for configuring. We will now open the ping-pong actor spec file from this path. The Scalar Kafka client provides us with a nice test kit that includes embedded Kafka server. This is the Kafka server. We now need a producer who will place messages on a queue. We will use a thin, lightweight wrapper for the Kafka Java driver named Kafka Producer. This is the code for Kafka Producer. This part of the code is the helper method to place the message. As we said earlier, the ping actor should be terminated after getting 3 messages. This is the code for fulfilling this condition. We also mentioned that the ping actor should place Pong message when he gets a ping message and a game over message before it terminates. This is the code for this condition. Here, the Kafka server provides a consume method, which has a built-in assertion that we can use to verify that the correct number and type of messages that are placed in queue. We need to apply the same condition for the Pong actor, and this is the code for the same. Next, we want class for ping pong message. This is our ping pong message class with text as string. This message will be sent to Kafka and sent back from Kafka. So we need to serialize and deserialize it. This is the code for doing it. Next, we will learn about ping pong consumer. Scalar Kafka client provides Kafka consumer actor and Kafka producer actor that are interfacing with Kafka consumer and Kafka producer drivers respectively, and are easy to integrate within the actor system. This is the code to do it. This is the code for message extractor for ping pong consumer. Here the consumer actor accepts an actor ref as a parameter. Actor ref acts as the downstream actor, which means it will pipe all messages from Kafka to that actor. So we will be using the parent actor itself, hence we deliver self as the downstream actor ref for consuming and submitting messages to Kafka. This is the ping actor.scalar file. For pattern matching convenience, we will use Extractor in our receive method. Also, we will use consumer records class, which represents a batch of key value records consumed from Kafka with a nice extractor method for pattern matching. Great! We now have our consumer and producer actors set. We will now be sending them subscribe and submit messages. This is the code for doing so. We can now start playing ping pong. This is the code for playing ping pong. This is the playing ping pong method. Let's run the project. Before running, make sure you have running Kafka instance. So, need to start Zookeeper and Kafka broker. We need to create 2 topics. Let's create them. First topic is named ping. You can see that topic ping already exists, as we have done it already. We will now create next topic named Pong, and this is also already present. So let's run the project. You can see that project is being run. This is the first ping, and this is the response ping. This is the second ping, and Pong, and this is the third ping. And after this, we get ping actor ending the game, which is a game over message. And here the Pong actor is being terminated, and the Kafka producer is stopped. This is the output which you will get. This brings us to the end of this video. Here we learned about the relationship between Akka and Spark and Kafka and Akka.